All right, guys, so the sheet we went over last time, it's got the important times. Of course, our finals on the first day of finals, which is good and bad. I'll be in my office right before class, and then our final starts at 9:25, which is nice. Come on time, you're early, that's good. So make sure you know that. I got the practice final up here if you don't have that. The answer key that I'll give out in a little bit. So really, it's kind of it's a little bit like yesterday again. You guys can focus on whatever you want to focus on asking. You can, if you don't have questions, you can try the practice final out because I'm going to give the key out in a bit. I've been showing the labs that in my math lab there's a little link called study plan. And if you click on that link, study plan, you can bring up all chapters and pick a chapter and do a quiz. It can create a quiz for you. It's not going to affect your grade at all. It's just little ways to kind of review and see what to focus on. It's got a recommendations thing, and when I look at it, of course, I don't have anything to recommend to me because I haven't done any of the homework. I suck. But I'm curious if for you guys, it actually has specific recommendations. I would be interested. Maybe next lab I'll have somebody pull it up so I can take a look. Okay, well, that's something to look at if you want some more, another place to go review. I will tell you this, if there's a lot of homework you haven't done, you need to weigh what it is you need to focus on versus completing the homework. Right now, the most important thing is to get ready for the final, right? So if there's like a whole section you didn't do because you already knew it, you didn't feel like you had to do it, then don't frickin' do it. Just kind of make sure you know it and then keep going. Focus on what you need to focus on to get ready for the final. The final is heaviest weighted single thing, right? Homework is worth 5% of your grade. So it's not going to, doesn't have any chance to compete. By the way, students are often freaked out about this. You have basically 75% of your grades set. And the final is roughly like 25%, right? So it's 1/3 as powerful as the grade you already have going in. So unless you make a really high or really low grade, it's not going to really do much unless you're really close to something else. If you're just barely passing, it could take you down. Or if you're just barely failing, it could bring you up. If you got a B-, it could give you an A-, it could take you down to a C+ or vice versa. You guys kind of with me? I mean, it really isn't like the determination of your future. No, it's not. Okay, so if anybody needs, I've got the practice final and a few other recent handouts. Is there anything you want to kind of focus on? Or do you guys just all wish I would give you the key right now? Too bad. I say that as if it was an option, just the truth. I love you guys. So if you have something that you want to focus on, nobody's asking anything, it's your floor, yes? Okay, what about this? So here's one like with the log properties.
Oh, I guess it's not.
Or like the log equation maybe? Or just the basics of like simplifying logarithms? Or graphing logarithms? Or everything?
J.
Or this one? Or number one? This one? Alright. So guys, 3J. How would you solve that? just to remind you guys, if it was a slightly easier problem, like, instead of that, if I had this, log base 5 of x equals 2, how would you solve this thing here? Yeah, 5 squared equals x. Isn't that crazy? So what if I had to put instead log base 5 of 2x minus 1 equals 2? Doesn't matter, right? I changed the inside, but the first step doesn't care. That log is in my way. Let me get rid of it by rewriting this. So 2x minus 1 equals 5 squared. Yeah, I'll hit x. And then you just solve this like normal. 2x minus 1 is 25. Add 1 divided by 2. Bam. Okay, cool. Now, so I'm working my way up here. So the problem with this problem is there's 2 logs. If only it was 1 log, then I could do exactly what we just did down here. So what allows me to rewrite this as a single logarithm? Yeah, there's a minus in the middle. Logs are powers. Yeah, I would subtract powers when I was dividing the stuff. That's the property of logarithms. Now it looks basically like this one. Right? It's log base 3 of something equals 1. Well, I can rewrite that as 3 to the first is that thing. So this would be 3 to the first equals this business. What would I do next here? Yeah, I got a variable part that's in the bottom. That sucks. So I want to lift it up. Multiply by 2x minus 3. Both sides. Bam! So I get x equals x equals 6x minus 9. Okay, see now that's not too bad. So subtract x, add 9, x is 9/5. And does 9/5 make either one of these logs freak out? 2 times 9/5 is 18/5. Minus 3 is 3/5. So that's fine. And x is positive, right? So you got it at the end. So it's just like a radical equation. You got to check to make sure that none of the possible answers makes the equation freak out. In that case, they have to be 0 or bigger inside. Your logarithms, they can't even handle 0. They can't be 0 or negative, whatever the inside is. And 9/5 does not make that happen, so it's fine. There's that one. Oh yeah, dude. All right. What are the 2 main equations for a line that we've learned? Mx plus b. You got the old standby, and then you got the slightly more complicated one. We'll get it started. This is really just the slope formula solved for the y's. Right? Multiply the x's up, bam. This just comes right from the slope formula. This one is good for when I know the y-intercept. This one's good for when I don't, when I have some other point. What is it that I know in part A? What's this? No, come on. What's special about that point? That is a special point. Aw. It is the what? Y-intercept. How the hell did she know that shit? Because how do you find the y-intercept? You make x0. So that's the y-intercept. So what's b? What's b? -5, because b is the y-intercept. And what's m? So part A is awesome. It's just a plug and chug. I tell you everything directly. You're like, why can't you do that always, Jeff? Because then you wouldn't know shit. So plug in the m, plug in the b, done. That's the bestest problem. But what about part B? Part B, of course, is a bit more difficult. I tell you it's parallel. I don't tell you the slope directly, but I tell you it's parallel to this dude. Yeah, if it's parallel, the slopes have to be the same. So I know my slope is 5, and I know a point is -4,2. So now I just got to plug and chug into the correct formula and use this guy. So yeah, you got to know these two. I love it. And I love the student. One student got upset at me in an upper level course. He's like, why do you make us remember all this stuff? In the real world, I would have a little cheat sheet. I'm like, I'm not in the real world yet. But more importantly, it has to do with, I hope to God that through memorizing these, you pick up on why they make sense. So no, I'm not just going to let you plug shit into an equation that's on a sheet. You got to know these. And the best way to memorize something is to understand why they make sense. So now I just got to plug and chug, right? We figured out the slope because it's parallel. If it would have been perpendicular, what would the slope have been? Yeah, -1/5. It's the negative reciprocal, the total opposite. Parallel, exactly the same. Perpendicular, totally opposite. So now I just got to plug and chug y minus the y piece equals m. X minus the x piece, yep. And then you can clean that up. Distribute the 5, add the 2. Cool. Okay. Yes. Oh, okay. Okay. So since I didn't say you could just make an XY table, making an XY table by itself is not, it doesn't create itself. You have to kind of know what to plug in. What is it easy to take log base 3 of? Give me a number that it's easy to take log base 3 of it. Log base 3 of 3 is easy as shit. But what do I make x so that I get a 3 inside here? 4. If I make x 4, isn't this log base 3 of 3? So yeah, you got to think a little bit. What do I want to end up inside there so I can actually do it? And what is log base 3 of 3? 1. Because 3 to the first is 3. It's amazing. What else is easy to take log base 3 of? 9, sure. 1? Yes. Yes. How do I make a 1 inside? I think that might be what you're thinking about. Yeah, if I make x2, I get log base 3 of 1, and what's log base anything of 1? 0. I raise anything to the 0 power, I get 1. Anything except 0, 0 to 0 is freaky but screwed. Ah! Okay. And then, I mean, one more point you could do. This might be just a little bit freaky. Huh? Yeah, 10. That would make log base 3 of 9, which is 2. We do one more point. Log base 3 of 1/3 is easy. But how do I make a 1/3 show up? What do I take 1 away to have 1/3 end up there? 1 and 1/3. It's just 1 more than what I want to be in there because I take 1 away from it. So if I make this 1 and 1/3, I end up with log base 3 of 1/3, which is, what's log base 3 of 1/3? Negative 1. I've got to flip the 3 to make it become 1/3. Okay, and now you just plot those points. You know the basic look of a log, or you should. What's an exponential look like? Exponential. A to the x. Yeah, it looks like, wow. So what's a log look like? Right, because they're inverses of each other. They're going to be... So a logarithm looks like that. I can move it around and stuff, right? So if you wanted to, you could do this problem using a shift. How would it shift the normal log function? It would just shift it to the... No. Right 1. Because where is that minus 1? It's with the x. So it's going to be left or right. And in this case, it's right 1. So you can do it that way if you want to. But now you just plot those points. So 4 goes to 1. 2 goes to 0. 10 goes to 2. Oh shit, that's way over there. And then 1 and a third goes to negative 1. So there's going to be an asymptote right there. Where's the asymptote normally for a log function? Where is it? Where's the asymptote for the exponential? X-axis. So where's the asymptote for the log? Y-axis, because the logarithm is the inverse, the x and y switch. So what did everything do in this function? Everything moved to the right 1, so the asymptote's going to move to the right 1. Bam, there's the wall. Logs have walls. There's some joke in there about log cabin bullshit. Logs have walls. Exponentials have floors. So that one is number 9A. You always have a couple different ways to do that, either by using shifts or by XY table, if I don't ask you to do one or the other. Yes? Oh, all right. Let's see. So 13, of course, you got to love it. I just got tired at the end. And that's relatively recent, so I figured you have examples from recent times. Let me ask you this. Can you guys create the equation of an ellipse? Bless you. Whose graph is this? Uh-oh, she just left. Shit. Well, they probably give so much time. Sure. I was like, she's fast. No, this is not a ellipse. I love that. Ellipse. This is an ellipse. Sure. So that has this graph. Oh yeah, just barely. So what's the important parts of this ellipse that tells you what goes into the equation? What's the equation going to look like? What's going to be in the middle of the x squared and y squared? Plus. So now you just got to figure out what goes down here. How far out on the x did I go? 2. So what's going to be underneath here? 4. Because the bottoms are the squares of the lengths, because it actually kind of goes along with this. It goes on the bottom of the y. 1, because 1 squared is 1. Alright, so that's an example of a problem I could totally give you. Wink, wink. Could show up. This kind of problem could show up. Say again?
Why isn't it that exact problem? Make life a lot easier.
That's why. That's too much. Yeah. I hate that. I know you're kind of joking, but there are students out there that think that teachers don't care for them if they don't make everything easy. Whatever. So someday you'll learn if you think that way. So here, let's just do a normal straight up problem. You know, definitely going to put a problem on there like this one. What you got, Jeff? Yeah, how can he tell this is a circle? The x piece and the y piece have the same coefficient. So do I need to divide by 16? No. I could do everything as if it was an ellipse. It would still work, because the circle is just a special ellipse. But in this case, I can leave it like this, because what can I see now? I can see that the radius is 4. And again, everything's squared in ellipses and circles. So it's just like the bottom of this, we have to square root to see how far out. We have to square root this to see how far out to go. Same idea. And where's the center going to be? 2, 1. I love it. Over 2, up 1. Kick ass. The circles should be like, please, dear God, Jeff, give me some circle problems. They're so nice. Yes, Sean?
Is that a hyperbola?
Why is it not a hyperbola? Because there's a plus in the middle.
Right, got it, has no negative, my mistake.
That's all right. So now you just put 2, 1, you put the center there. And then from there you go 1, 2, 3, 4, 1, 2, 4, 1, 2, 4, 1, 2, 4. Wow. You know, all right. That should be easy. Once you figure out the center and the radius, the graph has got to be easy. Plot the center and go out. Whee! Right? And I'm going to give you, obviously, I suck at drawing circles, so if you do too, I'm not going to take points on it. Just don't do this, my God. That's an approximation of this. No. Now this is definitely a hyperbola because of the minus, yeah. And hyperbola, it doesn't matter if these were the same, it'd still be a hyperbola. It'd just be the rectangle I draw would actually be a square. Right? So it'd have like a circle inside, but the hyperbola would be on the outside. It's still a hyperbola. Doesn't matter. What can I see from this? Where's the center? 0, 0, because these have not been shifted at all. How far on the x-axis do I go? 3, both sides, so I like it. How far on the y? 5. And then to do this, it's just You go 3. 3. Now, what does it sit on? What axis does it sit on? X-axis. So it's going to look like this. My God, if you give this to me as the answer, so 3, -3, those are actual points, right? Because it sits on that axis. On the y-axis, they go up 5, 1, 2, 3, 4, 5. Put a little X there or something. 1, 2, 3, 4. And then I put what? A box. My Python fans are so box. And then through the corners, I draw my asymptotes. And then I just fill it in. Nice, fat, well-fed hyperbola. If that term would have been first and if these would have been switched, it would have been up here and down there. It would have been up here and down there instead. If this would have been a plus, this would have been a plus, it would have been the ellipse inside. But instead of doing this, it's doing, oh, and then it was unbounded. Ah! Here. So it goes, oh shit, now it's got to meet, oh, it's all contained. Yes?
So, and then if the x and the y were reversed, then it would shift it would be, up at the top and at the bottom. I don't know if you'd call that horizontal or vertical.
So it sits on the axis for the variable part that's positive. What's evil about, now here, I would not give this question, but what would be evil about this question here? Yeah. That's just pure evil shit. You have to realize you got to divide by -1, so then it would actually be the y piece that's positive, so it would have to be vertical like that, yeah. That's just evil shit. 10 years ago I said, give me 10 years and maybe I'll be this evil. Not quite yet. I'm almost there. Not quite that evil yet. 5 more years maybe. Yes. It'll be 5 more years from now before I know it. Are you that evil yet? Yes. Which one? 2A. Oh yeah. Now I know there's people out there that are like, alright, if I just study everything else, I can just skip these questions. And my life would be so good. But if you're going to take pre-calculus, you want to understand word problems. Right? Okay. So it's on you if you decide to just skip these things and not study them. When you get to your pre-calculus, you better not hold it against that teacher or me. That's your choice. The first step in a word problem has nothing to do with math. It doesn't have a damn thing to do with math. It's English, it's words. What are the players in this problem? What are the players? It's a triangle. It's the sides. So what are the sides? Be nice to yourself. There's one side. There's smallest side. And then there's largest side. Use the language in the problem so it's easy to go back and forth, so you can remember where things came from.
Can we put the x on the small one? Can we label the small as x?
Yeah, why do we need to do that?
Because it doesn't say anything. It's only words right now. So we
All
need
right.
to put in variables.
So technically you can make any of these x. There is one choice that makes this problem infinitely easier. Which thing should I call x? The smallest one. Why?
One side
One side is blah, blah, blah smallest. Largest side is blah, blah, blah small. Both the other sides depend on the smallest one. So if I give it a name first, the other names I can put together easy. Now there is a way to do this by I can call the one side x, but the equations for the other two would be disgusting. But if we call the smallest one x, then what's the one side? 3 less than twice that. Okay. What's twice the smallest? What's twice the smallest? 2x. Now what's 3 less than that? Is that right? So a lot of people put 3 minus 2x, which leads to negative side links, which leads to black hole, Earth is gone. So don't do that shit. So if you end up, most of the time, you're not going to have an expression like 3 minus 5x in a problem like this. If you do, most of the time that means you made a mistake. And then how about the large one? You can't go wrong with the large one. Yeah, 3 times the smallest is 3x. 5 more than that, plus 5. If you turn that around, you're fine, because addition is commutative.
Oh, I can't see. Hold on. Oh, me. Oh, he says it's kind of hard to see, I guess, because I can't read the last word.
Do you have the practice problem, Sean?
Yeah.
All right, and then what can I do with these? I'm always curious if somebody's out there like, I'll tell you what to do with those. If I add them all up, it's got to make what? 62, because that's the perimeter of the triangle, right? So if I add up all the sides, I get 62. I've got math names for the sides, so now I can set up a math equation representing that relationship. This side plus this side plus this side has to be 62. Yeah, and now it should be easy as shit, right? This step should be the easy step. Has to be the easy step. If this is not an easy step, then you should not pass. Yeah, you should not pass. At this level, this has got to be just second nature, in your sleeve, that kind of shit. So you get 2, 3, 6x plus 2, so I can subtract 2. So the next is 10. 10 what? No, 10 what? Inches. So the small one is 10 inches. And then you just plug a 10 in into the other two and figure out what the other two are. Yeah. Oh yeah, bees, yummy. Bees and parrots. All right. So a good idea. We could have drawn a picture up here. I just went straight for the players. You could draw a picture here. It's always a good idea, really, to draw a picture just to anchor yourself. So what are the players in this problem? It is a rectangle. What are the players? Give him a break. He's like a souffle that hasn't dropped. Yeah, length and width. I love, in a math problem, I got my art critics out there. Which one is going to be just a letter? Width. Because the length is blah, blah, blah width. I got to know the width first, and then I can make the length easy. So the width is x. Yeah, the length will be 3x plus 2. Then they tell me the area is 261 square meters. 261. How do I get the area of this rectangle? Yep. length times width has to be 261. So now you can what do I need to do now? Distribute and what? Get it equal to 0 because I got an x squared term, right? Which means I have to do what with this? Factor. Yummy. Yes, ma'am. What's the first step in factoring this? Yeah, 3 times 261. $783. So you need two numbers that multiply by negative 783 and add to be 2. I don't like the number 783. Looks shifty. I don't like it. So what I do instead is take things that add to be 2. That's easy as shit, right? One's going to be negative. How do I know that? They got to multiply by negative numbers. So one of them is going to be negative, one is going to be positive. So they actually have to be two numbers that are 2 apart. I can make a list of those. Easy. Making a list of factors, 783, maybe not that great. So what are two numbers that add to be 2?
1.
For example, let me start us off. 22 and 20. Wouldn't they add to be 2 if the 20 was negative? Well, what is 22 times 20? I like it.
400.
I'm going to contact the elders. 440. Shit! Right? It's not 783. It's kind of close. And they just keep going. Sorry, what? 27 and 29, if the 27 is negative, that'll do it. 27 times 29. These two guys. I want you to realize, yes, this takes just a little bit of time. Yes, you got to play with the numbers a little bit, but my God, you go 22, negative 22, small. 23, 21. 24, 22. 25, 23. I mean, until you get to the right one. That's awesome. So sure enough, this times this is negative 783. Now what do I do with that information? I take this middle term and I break it up. So minus 27x plus 29x minus 261 equals. So if you find the two numbers that make the numbers work out, multiply to be this, add to be this, the grouping will work, period. That's why this thing is called the surefire method. What comes out of these two? 3x. So what has to come out of this? 29. X minus 9. 29 times 9 is 261. Come to find out. And then finally you get x minus 9 times. So you get x is 9 or x is negative 29 thirds. Are both of those answers valid? Mathematically, yes. Physically, no. Can't do that. What was x? The width. So the width is 9 meters. So that makes the length 3 times 9 is 0 plus 2. 29 meters. Bam. You can check it. 29 times 9 is 261. don't think I converted anybody that was planning on skipping these, but I don't do so much. Which one? This guy? Okay. What do I have to use on this guy? Anybody remember the name? Not conjunction. Conjugate. Yes. What's the conjugate of the bottom here? Yeah, square root of 5 minus square root of 2. And then you just FOIL the top and the bottom. Oh, let me give you guys the answer key before I forget totally. Ah, useful job. So it is 5 going 3. But the way you say it, so 5 goes in a 1, so there's 1 G out, 3 left, 3 G left. So the way we set it, since we work in division, is actually the way it works for straight. So just to make sure you guys remember this, next week there are no classes, there are just finals. So come Tuesday for the final, don't come Wednesday to lab and weird shit. It's over. Yeah. Why is it what now? Sorry? Guys, wait, guys. Guys, ladies. Yes, hey. Stop. Yes.
You have G5, or I'm sorry, G8 inside the letter.
Sure.
And when you pull it out, you just have G and then W squared, but there's the W, like, isn't there only one left over when you pull it out for the W and 3?
Isn't there one left of what? Sorry.
Just when you go to the final.
Yes. Okay. So if it was fifth root of G5, well, what's the fifth root of G to the fifth? If that's what it was. Say it more specifically. G. So if I put an extra G inside, stay with me now. If I put one more G inside, it would still be G, but then there's an extra G that gets left inside. So how many extra G's are there? 3. So all 3 of those get left inside.
Oh, we pulled out one.
So 5 goes into 8 once, with the extra 3 left.
Now, for your W, there's
5 goes into 11 twice. I got 2 groups of 5 W's, so I take a W out for each time, with 1 left. I like it. And so forth. Oh shit, I forgot. This one, yeah, I said I was going to.
So that's not going to be on the final.
Of course it is. What are you talking about? Did I show you guys how to do this? Let me show you. You're going to have to do this by hand. If the answer just magically appears, I ain't taking that shit. But did you guys notice, do you see a button that says matrix? Interesting. So if I hit that, I can actually make a matrix. Get out of there. Go to edit. I can actually make the matrix. Whoops, there it is. You guys see where those numbers came from? 3, -1, -5, -7. I can make the matrix. And then what is it that I want to do to this matrix? I want to reduce it. RREF, row reduce. So if I get out of here, go back to matrix, over to math. If I scroll around, I find RREF, row reduced. And I can row reduce that matrix. Bam! And there's the answer, 2, -2, 3. All right, well, and even if you don't see how to do that, I don't care. I'm not going to test you on doing it in the calculator. It's just if you happen to know, you can check your answer. But hell yeah, it's going to be on the freaking final shit. So, I mean, if you want to see that done or something, you can come to the lab after and ask it, or you can come to my office before the final, or you can, I don't know, go back and look at the notes from the matrix section. I love you guys. What? The thing we studied is going to be on the final? Harumph. Harumph, I say. I object. Overruled. By the only one whose vote matters. Alright, guys. I'll see some of you in a few minutes, and I'll see the rest of you on Tuesday. Monday's a holiday, so don't come out here at all.